continue. So as we did in part B, we have this sequence or these patterns, and then we realize that we cannot determine the difference, means that we cannot determine the next two terms by using the difference because of the difference behavior that happens here. However, remember that when I've been checking these observations, these differences, I didn't take consideration what is the sign. Means I didn't take consideration the positive and negative sign. I ignored the negative and positive sign. So in second step, we say we have to think outside the box. So if you think outside the box, you have to take out the considerations of what? Of the denominator. So this is the consideration of the denominator. And hence you realize that the difference, what the difference means, that how are these denominators can be formed, the other ways of forming this sequence. So you can take 2 power 0, it is 1, 2 power 1, it is 2, 2 power 2, it is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is what? Is 32. So the next two, these are denominators of what? Of the terms. So this is the denominator of unknown fifth terms, this denominator of unknown sixth term. So then we went and then we rewrite our new sequence right now. But remember that the question asks us to determine this one and this one. So when we've been writing, we analyze against the sign. This is positive term, negative term, positive term, negative term. So this will be positive terms and this will be negative term. That's why we concluded that the next two terms after these 4 terms will be 1/16 and the negative 1/32. So if that's the case now, we are going for part C. So we have 1, 2, 6, 24, 1, 20. So the first stage, always you have to examine the differences, okay, or the relationship between these terms. So if you examine, because here this is the whole number, right? A sequence of 40 of whole numbers. So if you examine them, we find that these patterns or we don't have a common difference. So no commonality, no common difference. Okay, I will teach you about common difference in arithmetic progression. No common difference. No common difference between the terms. So this method will not help us determine the next two terms. So what you have to do again, so you have to think outside the box. So what should be the thought? We have to think in terms of multiplication, right? So if we think in terms of multiplications, we have to think about maybe a common number or what the sequence. You have to formulate the sequence, how it has been. So you go for the second stage. Second stage, we say that identify the other form of 40 of forming what? Of forming the same sequence. The same sequence. So what the other form? For example, we think that if we have 1 times 1, we get 1. Right? And then if we have 2 times 1, which is this one, we take 2 times 1, or let's say we take the answer of the first product, which is 1. If we multiply by 2, we get 2. Right? And hence we continue. So the next terms, that will be the third term, will be formed by the product of 40, the product of the second term and the next nth term. Okay, so it means that the next term will be we have to take because here we took the first term, which is 1 times 2, we get 2. And then now we take the second term, which is 2, we think we should multiply this 2 by which number to get 6. Just like here, we took 1 times 1, we got 1. And then we have to think, so we take 1, what should we multiply with 1 to get 2? So the answer is 2, so 1 times 2 is equal to 2. And again, we say that we have 2, we have to think, what should we multiply with in order to get 6, which is the third term? So the answer is 3, right? And then we say that, because we can even just, let me just rewrite the whole sequence here so you can see the increase. So we take 1, we multiply by 1 to get the first term, which is 1. Then we take the first term, which is 1, we think, what should we multiply with in order to get the second term, which is 2. So it means that 1 times 2 will get 2. Then we take the third term, the second term, we think, what number should we multiply with in order to get 30, to get 6? So the answer is what? Is 3. So we are forming the patterns, right? And then so we have what? The third term. We take the third term, which is 6. We have to think, what number should we multiply in order to get the first term, which is 24, right? So the answer is what? 4. So 6 and 4 is equal to 24. Then again we take 24, right? We multiply with what? We think, what number should we multiply with 24 in order to get to 120, right? The answer is 120. So this one we have to take 5, because 5 times 4 we get 20, so we write 0, we keep 2. 5 times 2 it is 10, then plus 2 is equal to 120. So if that's the case now with this arrangement, it means that we take now the fifth term, which is 120. We think, what should we multiply with in order to get the sixth term? So in order, and then the next questions we say that the answer of this part, which we don't know by the way, which is dash, we have to think, what should we multiply with in order to get it, the sixth term? So we have to analyze this sequence, because these are the terms. First term, right? First, second, third, fourth, fifth. So even the answer of this, it means that the fifth term will be the multiplier for this case. So it means that we have to analyze. So if you analyze this arrangement, we find that it is 1, then 2, then 3, then 4, then 5. So this is the series of 40. This is the sequence, or this is the sequence of 40 of natural numbers. So if natural number, the next number, if the common difference between them is 1. So common difference between this and this is 1. Common difference between this and this is 1. Common difference between 4 and 5 is 1. So if it is 1, so even the common difference between the unknown terms, it will be what? 1. It will be 1, which is 6. So you take 1 plus 5 is 6. Again, the common difference between 6 and unknown terms is 1, so it will be 7. So the response here is 6 and here it is 7. So 120 times 6. So 6 times 0, it is 0. And then 6 times 2, it is 12. So you keep 1. 6 times 1, it is 6. So you have 720. So this is the fifth term. Then we take 720. We multiply with 7. 7 times 0, it is what? 0. 7 times 2 is equal to what? 14. We keep 1. 7 times 7 is 49. Plus 1 is what? 50. So then this is the result. You see? So the goodness of the sequence tests you your level of thinking outside the box. Right? That's the goodness of this, because you have to think. And that's the beauty, and that's the goal of learning mathematics, in order to teach you how you can think fast and how you can think around the problems that you've been given. Because even if that after you graduate, we're expecting you to solve real life problems. Right? So if that's the case now, we conclude that, we say that the next two terms of the given sequence are what? 720 and also what? 5040. So this is the response. Beautiful? Yeah, it's beautiful. Then part C will be given 1, comma negative, part D, excuse me, this is part D, comma negative 1, then 1, comma negative 1. So the question is, we are determining the next term, which is the fifth term and the sixth term, right? So if you examine this pattern, this is the first term, second term, third term, fourth term. So we call that this is the pattern of repeated terms after one term. What does it mean? This is the first term, right? First term. So this is the first term. So the first term has the same value with the third term, right? So if that's the case, even they will have the same value with the fifth term, because they are odd. Because we have the odd terms. So these are the odd terms. So even if that will be, I want to know the seventh term. So they will have the same value, the seventh term. So if that's the case, we come to the negative term. So this is the second term. So suppose second is even number, right? And then this is the first term. So the second term is negative, the first term is negative. So even the sixth term will be negative, right? So if that's the case, the fifth term is 1, and the sixth term is negative 1. So the sequence repeat as long as several times, as well as it can repeat or as well as we can write. So if that's the case now, just to conclude, we say that the next two terms are, right, are 1 and the -1. That's the response. Again, below, this is a telephone number which you can offer God, who have given me this business to do it. It means to teach you and to impact your life and to change your life. You can offer your thanksgiving, your free-willing thanksgiving offering in order to participate in the running cost for these programs, for this online training, because there is a high running cost to make sure that many lectures of basic mathematics or O-level secondary educations will be in air, right? So that we can, so any students that can learn them at any time and at any, and anyway. So that's what has been written, thanksgiving off. Off is abbreviations of offering. We don't need the help, we need just the offering. So it means that the telephone number is what? 0759745331. So even if you go through the descriptions of this video, you'll find the telephone number, even the account number, if you want to do the bank transactions. Thank you very much for participating, and thank you very much for understanding what I presented to you. So then we have solved the first question in exercise 5.1 of chapter 5 for sequences and series for the form series. Now it's a time, I solved the 4 questions. It's a time to give you a homework, right? So this is, we call it just homework 3 or homework. So this we call it homework. So it's a time for homework, right? And the homework still, we are still solving the same exercise, right? So this we can call it just the homework 3 because it's lecture 3. So homework 3, and this we call it part A, right? Homework 3, part A. So I have 2 questions that are selected to mean that so this will be in a sequence, right? So this will be example, that it was example 5, right? So this will be example 6, right? But this example 6, I took from the book called the Basic Mathematics, or Secondary Basic Mathematics, book 3, right? For those who are using the Tanzania curriculum. So this is question number 6, right? So it's question number 6, or it's question number 9. So it's question number 9 in exercise 5.1, page 141, right? So the question said that, write down the next two terms, write down the next two terms, right? The next two terms of the following sequence. So it's a fraction of the following sequence. And this sequence is 5/2, 3/2, 7/3, 5/3. Okay? So that's the question. And then you have example 7. Right? Example 7. And this example 7, I took it as question number 3 in exercise 5.1 of secondary basic mathematics book 3, right? So the question asks you that to find the general term of the sequence. So these questions is not for this part, it's for the next part. So just to do that one question. Okay? So submit your homework submit your homework. Submit your homework on what? Comment section. Say comment section. Comment section of this video. So submit it, and I will try my level best to go through your homework to see whether you have understood or not. So that's all about the first part, and basically it had 2 questions, test you. So let us go to the second part, right? And this we call T part 2. So we call T part 2. Part 2 of exercise 5.1. Okay? So this part 2, I can call it finding the general or find terms for given n step. So I will be teaching you how we can find terms. How we can find terms for what? For given n stem. So if you are given the n stem, how you can use the given n stem to find terms. N stem to find what? To find other terms or the next terms. Means finding terms by using the given what? The n for the given, by using the given n stem. That the concept that you have to learn after 3 of this subject. And before this part, excuse me, I think that we have to teach about finding the n stem first. Finding n stem, excuse me. Just do this minor correction. This will be the third part. Finding. So this is finding the n stem. How can we find the n stem of the sequence? N stem of the sequence before of any sequence, right? Because I will teach you how to find the n stems of arithmetic progressions or geometric progression. So this is any sequence. Might be either arithmetic or geometric or neither of them. So I will be teaching you how to solve problems on this part by solving the following question. This will be example 7. This example 7, I took it from exercise 5.1 as question number 2. So refer exercise 5.1 of the book that I've mentioned. So the question asks you that find the n stem, of the sequence. Find the n stem of the sequence. So find the n stem of the sequence 1, 3, 5, 7, etc., etc., etc. So it means you continue at the question. So let us solve the problem. Solution. So we are looking for the n stem. I define what the means of the n stem in session 2. So you have to make sure that you go through it. So solution. So find the n stem of the sequence 1, 3, 5, 7. If you examine this sequence, you find that the sequence of 40 odd numbers, odd natural numbers, or odd whole numbers, right? Or odd counting numbers. So there will be following steps. The first step we say that observe or identify, observe what? The difference between terms. Okay, I'm writing this for your future review. So 1, 3, 3, 5, 1, 7. You'll be given 4 terms. So what the difference between the first term and the second term? Difference is 2. What the difference between the second terms and the third term is 2. What the difference between the third term, which is 5, and the fourth term is 2. And what the difference between the first term and unknown, what, 6th term, right? If in case that we are finding 40 for the terms, we might say that it might be 9. So you can continue as long as you can. But today we are not looking the next term. So as you say that in the second part, we'll be learning there how we can find the nth term, right? To find the nth term, let me just repeat and then we can go through. So find the nth terms of any sequence. Later on, I will teach you to find the nth term for arithmetic and geometric progressions, the next concept. Stay tuned. But here I'm teaching you how you can find the sequence of any term without using the formula. You have just to think about how the formations of the sequence has been made or has been achieved. So find the nth terms of what of the sequence that one. So the first step, we say that observe the difference between them. And then the second step, we have to format the sequence by using another form. So that's what we are doing. So remember that in the previous example, that example 60, we are trying to think that how we can form the terms by using the previous term. So the first term here is 1. We took 1 times 1, we get to 1. And that's, yes, this first term. Then we took 1 times 2, we get 2. 2 is not a part of this sequence. So because it's not a part of this sequence, then what's going to happen? So because it's not a part of this sequence, so this way will not be helpful. However, that if we keep continuing that 2 times 3 is equal to 6, 6 is not a part of this sequence. So this approach won't be successful. So it has been successful for only example 60, part C, right? Example 5, part C. So then now, how we can form the general term? Look, the way we can form the general terms, we can use, it means that we can use it means that another, as we say, another form of formulating this sequence. What another form? So the other form, we say that we can take 2 times 1, and then subtract it by 1, we get 1. Okay, you can ask a question yourself, how do you know? Or how did they know that this is the way that you can formulate? You have to think, you have to use your mind, you have to use your intelligence on thinking and see how the sequence has been formed. No need of the formula by this point, at this point. However, that this is, I know that the sequence, it's a sequence of arithmetic progression, it's arithmetic progression sequences, but in this stage we are not allowed to use the formula. Right? I haven't talked about the formula. So 2 times 1 is equal to 2 minus 1 is 1. Then I can take 2 times 2, then minus 1. We get to 3. So 1 is the first term, and 3 is the second term. Okay? Again, so you take 2 times 3 minus 1. So 2 times 3, we get 6. 6 minus 1, we get 5. 5 is the third term of the given sequence. Then you have to think 2 times 4. Then minus 1. 2 times 4 is equal to 8. 8 minus 1 is equal to 7. So that's what the last term, so the last given term is 7. But the sequence is still proceeding. So if you proceed, for example, you go further, because this is the way we have 2 is common multiple, common multipliers, and then 1, 2, 3, 4. This is the sequence of the natural number. So we are examining something. It means that we realize there is a certain relationship, certain common relationship between the terms. So you can say that the next terms now, ask yourself, let me ask you, ask what will be the next term if this is first, second, third, fourth. The next term will be what? 5. Very good. So 5, then minus 1. So 2 times 5 is what? 10. Minus 1 is what? 9. So if you've been asked to find the next term, will be 9. Right? Etc., etc., etc. So we say that if we continue, right, with this basic operation, so 2 is common, so it will be there. Then we have multiplication sign. Then this is the sequence of 40 natural number. So if you have the sequence of natural number, right? Sequence of natural number, 1, 2, 3, 4, 5, right? Then we continue, the last term will be n. So if that's the case, it will be 2 times 40 n. Then we open and close the bracket, we minus 1. Then every terms we can get, it means that the first term we can get when substitute n is equal to 1, the answer is 1. If you substitute n is equal to 2, the answer is what? Is 3. Substitute n is equal to 3, the answer is what? Is 5. If you substitute n is equal to 4, the answer is what? 7, etc., etc., etc. So 2 times 5, this in In maths, we just write that is 2n minus 1. So this is our n stem. So therefore we say that the n stem of the given sequence, the n stem of the sequence is what? Twice n minus 1. So this is the response of that question. Right? Very good. I believe that you enjoy the beauty of what? Basic mathematics, chapter 5, sequences and series. The exercise is a little bit challenging because we're not allowed to use a formula. Right? So that is the first example. The next example, this is example 8. And in reference to the secondary basic education, basic mathematics, book 3, this is question number 8. I took it as question number 8. I want to help you on solving of exercise 5.1. Right? Of exercise 5.1, page 141. This has been written there in the subtitle. And then the question asks you as a student, find the general term. Remember that I used to go extra miles and teach you many concepts and teach you how to solve problems even more than what your ordinary teachers taught you in the physical class. The sequence, right? The sequence. Because in your ordinary classes, you might find that many questions in the exercise are left for you to try them. And sometimes you don't try them. And if you go to the exam, you will find those questions have been asked. Okay, so the question asks you that find the general term. So general term means the n stem. Remember that the other name of the n stem is general term, or 40 of this given sequence. So again, we can examine that given sequence. Okay? So if you examine the given sequence against that, if we observe the difference between the terms, then we can find something else. We say solution. Solution. Okay? So solution, we say that the first step, we say that observe the difference. Difference between what? Difference between terms. So if you observe the difference, the terms will be given 3, 6, 12, then 24. The next term, which is unknown, will be the 5th term and the 6th term. The difference between this number and this number is 3. The difference between this number and this number is 6. The difference between this number and this number is 12. So even the next one, you can identify possibly the different, because there's no common difference. It's just 3 times 2 is 6, 6 times 2, 12, 12 times 2, it will be 24. So 24 plus 24, it might be 48, etc., etc. But this can only help us to get the next term. How about 30, the initial 40 of the n stem? So you say that to find the n stem, you say that mean that the second step, find what? The n stem. So to find the n stem, we have to think how we can formulate this what? The given sequence in other form. In other form, with connections of vertical operation, whether it's with use of multiplication, that is commonly, or depends to the type of the sequence that will be given. We have 3, we have 6, we have what? 12, then we have what? 24, then dash, dash, dash. So if you examine these terms the way that has been related, we find that, these terms, they have kind of, you say 3 times, if you say 3 times 2, it is 6. And then 6 times 2, it is 12. 12 times 2 is what? It's 24. right? So how I can formulate the n step? Now, you know n step. Okay? So 3 times 2 is 6. So you can formulate like that. So for example, you can say that 3 times 2 or 3 times 1, this is equal to 3. Then we say that 3, or we say that this 3, which is 3 times 2, this is equal to what? 6, which is the second term. Then 6 times 2, this is equal to what? So this is equal to 6 times 2 is equal to 12. Then we say that 12 times 2 is equal to what? Is equal to 24. Well, this is kinds of the common number, but how can you generalize? This is the challenge. This is just I'm giving a challenge. So how can you generalize that, how the terms are related? It's a challenge, right? So even this approach also won't be successful. So the best way now, you have to think on keeping one terms common, right? So they said, so you say that keep the one terms to be common, that is 3. So I can say that this 3 times 2 power 0, the answer is equal to 3, which is the first term, right? And then so I have to think about if I take 3 times 2, but I raise 2 by 1, this will give me the second term, which is 6. Then if I take 3 times 2, which is raised by 2, 2 power 2 it is 4, times 3 it is 12, right? So I'm getting a certain arrangement or certain order, because we say that sequence is a series or is an arrangement of what of the terms in a particular order to form a particular pattern. So this already is a particular pattern, 0, 1, 2, and something else. And then say if again the next term will be 3 times 2 power 3. So 3 times 2, 2 power 3 is equal to 8, and 3 is equal to what? 24. So even if that you want to formulate the next term, it will be 3 times 2 power 4. So the answer will be what? So the answer will be 48, because 2 power 4 is 16. 16 times 3 is equal to 48. So with this sequence now, or this arrangement, you can find that the nth term, 3 will be common times, and then we come here. 2 is common also as a base of that exponent number. So because 2 is the base of that exponent number, then you analyze what you analyze the whole numbers, means the counting numbers for indices or for exponent. 1, 2, 3, 4. So this is the sequence of 40, sequence of equality of natural number. So it will be 3 times 40 times 2. So 3 times 2, for instance, that you want to get the fifth term, 1, 2, 3, 4, 5, the fifth term. So fifth terms, we say that n is equal to what? N is equal to 4, because the order or the sequence has started from what? From 0. So the sixth term, so we say that if for this case, say that is 0, 1, 2, 3, 4. Yeah. So we say if n is equal to 1, so we say that n, yes, so it will be n minus 1. Okay, so if that's the case, we say that we can a little bit adjust the difference. This is 1 minus 1. This is 2 minus 1. This is 3 minus 1. This is what? 4 minus 1, which makes 3. This is what? 5 minus 1, which make it 4. Why did they change? Because I want also to include the 0, right? 0 is a part of the sequence. So then we say that the nth term now is 3 times 2 power n minus 1. Why the nth term is like that? Because if you substitute, we place n is equal to the fifth term, it means n is equal to 5. 5 minus 1, 4. 2 power 4 is equal to what? 2 power 4 is equal to 16 times 3, 48. So therefore now we say that the general term, if you understood, please tell me in the comment section. The general term now is what? 3 times what? 2 power n minus 1. Remember that you have just to think outside the box. So after solving 2 examples in this part 2, Now, I want to test whether you have understood what I've been teaching you. So I have 2 questions for the homework. Are you ready for that? Will you do it? So this will be example 9. So it will be example 9. Example 9. And this example 9, I took it from the exercise 4.5.1 of secondary based mathematics, book 3. So I took it as question number 6. So if you have the book, you can check the question number 6 as the point where I took it. So this will be homework. So homework 3B. Right? So the question asks you that find the general term. Find the general term. Find the general term. Find the general term of the sequence. Of the sequence 1, comma -1, then comma 1, comma -1. This is the same sequence as the one that I taught you how to find the next term in example 5. So find the general terms of that sequence. Again, I have example 10, right? Example 10. In this example 10, I took it as question number 3 of exercise 5.1. The question asks us, find the general term. Find the general term of the sequence. The sequence 3, 6, 9, 12. This is still continuing sequence. First dot, second full step, third full step, full stop. First, second, third. Right? Great. So those 2 questions will be your homework. Make sure that you do them yourself. Don't ask your elder brothers in Form 4 to help you. Do it yourself. You can do it yourself. And then you submit or not. So the submission, submit your homework, submit your team in comment section. Right? Submit in the comment section. Comment section of this video. So you have to learn how you can write by using the computer, by using the mobile phone, this video. So if that's the case now, I would like to take you on to the part 3. Part 3 of these concepts of problem solving. And this part 3, I call it finding terms. For this part 3, I will end this session. Finding terms, right? Finding them. Remember that I will break in this session 3 into small videos of session 3A, session 3B, and even sometimes if I record the sessions of more than 2 hours or more than 1 hour and a half, you have to expect also to find session 3C. Bear that in mind. Okay, submit the comment section. So part 3. Saying part 3, we say I'm teaching you how we can find the terms for a given, okay, by using what? By using the given instant, by using the formula, okay, by using the given what? Instant. So how we can find by using the given and sorting instant. right? So I'm going to teach you this concept also by using examples, right? Well, so let us go to examples on this, regarding this concept. So this will be example. Example what? Tell me the number, 11. And this example 11, refer exercise 5.1, question number 7. So this is question number 7 of exercise 5.1 in the book of secondary basic mathematics in form 3. So the question asks you that the nth step, say the nth step, the nth step of a certain sequence, the nth step of certain sequence is what? 2 power n minus 1. Find what? Find the sum. Find the sum you enjoy the beauty of mathematics? Find the sum of the first 3 terms. Find the sum of the first 3 terms. So that's the question. I'm going to teach you how you can solve it, and then we click it and we move it. Are you enjoying the beauty of basic mathematics from 3 sequence and series? Tell me in the comment section. And also remember to tell me that you're enjoying this material. Where are you studying? Which school are you studying? Which regions are you come from? Which contents are you come from? Which country in Africa? Which city are you come from? Tell me in the comment sections, because I want to know how this program has been expanded to the millions of ordinary secondary educations students, right? So the question said that we'll be given the nth step of a certain sequence is 2 power n minus 1. Find the sum of the first 3 terms. So let me teach you how I can solve this problem, right? So this is still introduction. So we'll follow 2 steps mainly, right? The first step, we say that find, we say that use, let us use the given nth term, right? To find what? Given nth term to find the first 3 terms. So let me teach you how we can use it. So the formula for the nth term is 2 power n minus 1. So to find the first term will find when the value of n is equal to 1. That's the general concept. So 2 power 1 minus 1, the answer is equal to 1. Right? Good. Second term. The second term will find it when n is equal to 2. So this will be 2 power 2 minus 1. So 2 minus 1 is equal to 1. So it will be 2 power 1. So 2 power 1 is equal to what? Is equal to 2. Then we have to find the third term. So the third term, we say that n is equal to 3. So how will you find? So it will be